open source technology. So this is a small ESP32. So it's an ESP32 module, costs about $24, and it has a small screen device, so you can rotate, and which also presses the button. On the back it has Bluetooth Low Energy and Wi-Fi. It's got a connector for a battery, which I won't be using. It's got some I/O, and it can be powered from 6 to 36 volts, so it's ideal for running a boat. And I can program it over Wi-Fi or through USB-C. So this is the website I got this from. So this is M5 Stack, and this is the core DIN meter, it's called, and it's a general purpose device that can be used for any, can be programmed through Arduino or MicroPython. I'm going to be using MicroPython. I'm going to use, so that non-programmers can edit my code, I'm going to use a clever piece of tech called UI Flow, which is both a screen designer and a MicroPython plug and play programming kit. I'm going to show you how to do some basic programming with this. And this is going to talk through Bluetooth Low Energy to my Raspberry Pi. And the Raspberry Pi is going to connect to all the different systems. So it will know the state of the lithium, the state of the lead, the state of how much solar and how much current is coming through the shore power. And it's going to display it all on this screen. So I've come up with a screen design. This is my screen designer, and it allows me to place objects, so I can place different objects onto my LCD screen, and then I can access them through Python. So it actually writes Python code. So here you can see it's done, it's created my widgets for all of these devices with XY coordinates, fonts and colors. And then I can update these through Python, so I can reorganize my screen graphically and then programmatically program it. So what we see here is the top blue line is showing the mains, and that can either be coming from my 3 kilowatt inverter or through shore power. And to do that, I'm going to use this device, which is an AC sensor. So this can read in through its connectors AC power, and then it can out through actual a serial interface to the Arduino ESP32, can read in current, voltage and calculate the power being used live. And that is, there's going to be one of these behind each plug in the boat, and then those are going to be aggregated by the Raspberry Pi, so I know how much power is being used. So this uses this chip, which is a HLW8032, and that chip is designed for metering. So it's a tiny little chip that has all the pieces in it to meter AC power. So inside this circuit is one of these chips, and it has also an optical isolator, so it's a little bit safer than their standard design, which is, let me find it, I'm just looking at the specification for it. So standard design has the AC and then this, and then directly linked to a MCU, which then goes out to serial. So this also has an ESP32 in it, a smaller one, and it has this circuit is slightly different. It has an optical isolator between the 8032 and the MCU microcontroller, and that will allow me to know the current for the AC, and that shows and these are going to communicate using Bluetooth Low Energy through, I'm messing with a few things. I've tried MQTT, which seems to work. I'm looking at Bluetooth Low Energy is just as a way of transmitting basic data around the boat. So these will go into Home Assistant, which will then go into Signal K, and then via Node-RED. So it's all running on the Raspberry Pi, and then I can then do anything with that. So I can say, you turn this on one, and it'll, if you turn two of them, it will do the longest countdown. It won't just turn it off halfway through someone's use. And I'm going to have probably 3 or 4 of these around the boat wherever I use mains power, so that you can see exactly sort of what you're doing. And you have to if you want to use mains power, you have to turn this knob to get it for a certain amount of time. You can also press on off, which will give you like 10 minutes of power. So that's that. So what I'm going to show you now is how I'm going to program that using a piece of software, open source software called UI Flow. So UI Flow is currently on version 2.3. It's been around for quite a few years. It takes a blocky sort of like graphical programming, drag and drop, and it converts it into MicroPython as you build it. So you're writing MicroPython, but you're actually doing it in much higher level blocks. So here you can see I have a setup block which initializes a timer. It sets the timer to fire every 500 milliseconds, and then there's a timer callback down here, and at the moment it just plays a tone 2 kilohertz for 50 milliseconds. So it does a small beep, and you can plug these things together, drag them out of a catalog of pieces, and you can build the code, and then when you hit run, it deploys it as Python, MicroPython, onto the device, and then you can burn it onto the ROM, so it will run that MicroPython whenever this device boots up. So this gives you a very graphical way of programming, which can be done by, you have to understand a little bit of what you're doing and what things do, but a non-programmer can change this, adjust. So if you want to make this beep, say, half a second, you add another 0. Now it will beep for 500 milliseconds. It's 1,000 milliseconds a second. So you can change this yourself without having to read through reams of code. The code is actually quite a bit longer, and the blocky blocks from UI Flow is very shortened and simplified. But you can do anything pretty much you want to do in pure Python in the block language. So I'm going to put this on GitHub so that anyone who wants to, if you want to install these on your boat to look at your power, you can use some of my code. So so far I have built the test screen. So this is, it's not, I may tweak things a little bit, but it's got all the information on it, and I've done some test code that's going to test the device that will, the timer every 1/5 of a second, let's put this back to 50, it will beep for a 1/10 of a second, and then if you press the button, it'll do a 4 kilohertz beep for half a second. And I'm going to drive most of the interactions through timers, so I won't let you say press to switch on. I will press and say change state to on, and then when the timer fires, it'll look at the current state. If it's different, it will turn it off or on. So you can't sort of press this like crazy, because that tends to break mains devices if you flick them on and off too quickly. So it's going to have a little bit of hysteresis in there to slow you down. So everything will work without this. So if this is not powered up, the relay will be open and everything will just work. So this is not going to be a point of failure of the boat. And the failure mode is it works as an existing system, so you can plug stuff in, it just works. This only takes over if you power it up. So if I turn the 12-volt circuit that's running all these off, then everything will just carry on working. That's the first failure mode. If I have these running and there's no connection to the Raspberry Pi, the Raspberry Pi is off, then these will work in local mode. So they'll run the timer in local mode and they'll just control the local switch. And to do that, I'm going to fit some relays. So these are 2 relays, again plugged into a Grove connector, which will plug into the back of this. And then you can control it completely locally, so I can have it on the plug on for say 30 minutes or 10 minutes, and it will just work locally. So that's the second level of redundancy. And the third level is fully running, where it's all networked and controlled by the Raspberry Pi, and that allows me to never worry that if one piece goes wrong, I can't turn my kettle on or can't use my electric drill, because the default for all cases is it works. So that's that. So what I'm going to do now is just flash this to get it up to. I need to put in the runtime for MicroPython on. Burn the device. It's not an Atom. It is an M5 DIN mini meter, and I select the firmware. So this is burning MicroPython onto my device I'm going to use for power monitoring. So I have to hit confirm, and it okay, that burn was successful, so I just need to reboot the device by pulling out the USB, plugging it back in, and I am now in developer mode. I can select this, and I can select the device here and hit confirm. And now I can deploy this software. So if I want to run this MicroPython, I just hit this button, and within a few seconds, I am running that code on the device. And now, if I was to press the button, beeps for half a second, and if you listen, the device is beeping every half second, and I can change, let's make the volume of the beep a bit louder. So if I go into here and go into speaker, and I set the speaker volume, and just move this up for a bit, speaker process. Yeah, set speaker volume. And put this in settings, put this to 100%, or let's put it 95%. Now I can reburn this code. And you can hear it's beeping. And if I press the button, it beeps. If I turn the knob, nothing's happened. So what I'd like to do is just test the rotary encoder. So I'm going to add some extra pieces. So if I go into, let's have an if statement. So if I look at logic, take an if statement, put it in my loop. So if what I need to do is get the rotary device. So if the rotary device has rotated, then I want to clone this piece of, duplicate this, and set the label 0. Let's call that one a timer, and this one timer. So I've named the little, where it says 35 minutes as a timer. And now if I burn this, so it's burning over Wi-Fi, it's loading the new code. So now if I turn this, you can see the little green text is going up in steps of 5. So I could say, if I press it, it zeroes it. So if I do this up to, say, 20 minutes, and that will then turn the power on for 20 minutes once I finish it. So basically, it's working. What I need to do now is to port onto here a Bluetooth low energy receiver for receiving integer values for battery, in, out kilowatts, and then display those on the screen. I need to do a transmitter, a button for setting the power on for a certain amount of time, or power on and then power off. And I can do that using, I've got the code already written for JavaScript for a different project, so I've got to just port that JavaScript code into MicroPython, or I might find a Python library. So I'm going to be doing that in the next episode, and you'll get to see this working. Actually, let's stop this beep. So let's take this out of here, run this. Yeah, so now it only beeps if I press the button. I can control the say on for 50 minutes. And what I can do with this is I can find some variables and I can do some math. And do I have any strings? Let's look at text. So I can do replace trim prompt convert. Here we go. So if I take this string out, this will take text. So if I take this one out and put it in here, and in here I put text. I need a text. I add this. So what this is doing is so what this is doing now under the loop bit, if the rotary has rotated, true, then do set timer text. The timer is this label here, the little green one. I can now save it, you see timer, to equal get rotary value, multiply it by 5, and add the string m to it. So let's deploy that. Yeah, so now you see when I turn this, it now is in, it puts the little m in there and it's in minutes. So I'm going to do a little bit of tweaking. The black and the grays don't quite match on the device. Let's see what I can do about that. So if I go into move my screen over here and go into the screen designer and take this one, background, take it to black. This one, take it to black. Battery, take it to, I'm just moving the little pointer down right into the corner. So it was on a grey. Converting all these to black. And the final one is this one. Convert this to black. And okay. Now I need to over here. Close this. Redeploy. There. Now it's looking much better. The background of the numbers is black and it is still working, and I can set say for 35 minutes. So I'll get 35 minutes of power, and it's in black. Now what I'm going to do next is to add the other devices. I'm going to add this, which is the little relay module. This has a Grove connector, and it's basically 2 binary bits which switch the relays, relay 1 and relay 2. So if I plug this into the device, first of all, I need to find it here. So if I go into add a unit and I search for relay, and it's a 2 relay, confirm. And now if I look at that, it goes into port B. So on the back of this device, I have port A and port B. So port B is this rear port. So what I just need to do is to plug this into here. A little bit fiddly. Okay, so that is plugged into port B. Let me move this over so you can see both. I've now got a relay unit, plug this, and what that gives me is an extra menu on my carousel of blocks. So here I can say, let's take the relay and see what I've got. So here I've got basically two relay 1 status 1 to on. So if I take this and put it in the timer, I can do, and then I put a time and I put a sleep for so let's throw that away. I go to the time and I do sleep, and then I duplicate this, put another one in here, move this down. So what I'm going to do is set the relay 1 to on, and then I'm going to set the relay 1 to off after 100 milliseconds. So now if I run this, the relay is going to switch on and off every half second, and they'll be on for 1/10 of a second. So let's just test this. So you can hear the little mains relay clicking on and clicking off, and its little LED comes on. So at the moment, I'm purely testing the functionality, getting to know how this works. It's not going to be flashing the relay on and off during the in the production code. What I need to do is to have the relay set by the timer and also have it controlled by some hysteresis, so you can't turn it off and on too quickly. Okay, let's just stop that. Okay, relay is not on anymore. So yeah, so you can see you can rapidly develop with this, and very easily add features just by dropping lots. So here, I'm turning the relay on off. Here is doing the setting the timer value. Now, if you notice, that was it wasn't going clockwise, so I need to tweak that. So when you turn it clockwise, it goes up, and anti-clockwise goes down. At the moment, it goes the wrong way. And I can look at the Python. So this is all the Python that has been written, and this Python, when you hit run, is loaded onto the device, and it goes via Wi-Fi. And what I could do once this is installed on the boat, I just have to press the boot button when I power it up to get it into. Actually, no, I can actually do this while it's running. I should be able to update it over the Wi-Fi. Maybe it's a little risky leaving it in update mode in case someone hacks my boat and starts loading code into my devices, but fairly unlikely. But I probably won't leave them in developer mode. So if you have any questions, so my next stage is to look at the communications protocol. So what I'll be using is the Bluetooth Low Energy, which has a lot of blocks to control it and both receive and send Bluetooth Low Energy messages. And I'll be using that to communicate with the Raspberry Pi using the protocol for Home Assistant for sending numeric numbers across it, and for a timed switch. And then that will be connecting to my Bluetti inverter, and I have some open source software which allows me to connect through Bluetooth or Wi-Fi to my Bluetti inverter and read all of its power levels, and also switch, say, the mains inverter on and off. So this will give me full control of the boat from a small sort of $25 device. Will give me battery and solar and timed access for any mains. So yeah, it's a little bit unfinished at the moment, but over the next few weeks, when I work on this, I'll be putting this together, writing the code, and I'll give you an update once I get something finished. So what you've seen is sort of prototyping and messing with it. So I just need to write some production quality code, and I'm going to use this block language just to make it more accessible. I'll also be publishing the Python on GitHub, the MicroPython, so anyone can, this device or a similar device, because these devices are very standard. They're just ESP32s with a rotary converter and a small display and some I/O. You will be able to use my code and get similar features on your boat. Or if you've got an off-grid cabin, you could do this in your cabin. So thanks for watching, and yeah, I will see you next week with my next piece of boat technology. Yeah, I'm away from the boat for a few weeks. Actually, I'm heading over to France next weekend, and I'm going to take my Raspberry Pi and my screen, and I'm going to set it up on, I'm going on the ferry, 11-hour trip on the ferry to northern France from England, Portsmouth to Saint Malo. And I'm going to set this up and just do some seed testing with it on the ferry. So I should be able to see, using my AIS, other boats and cargo boats in the channel, one of the busiest shipping channels in Europe. And I should also be able to see my location and my path and my speed. And I won't have full sailing instruments because I won't be connecting to I'll just be using derived data from GPS and AIS. But it should give a good test of my system working in a marine environment where I can sit at a couch with it on the table rather than in my small sailboat. So I'll be testing it as I head across to France next weekend, and I'll try and make a video of that. So it'll be sort of boat technology running on the table on the ferry, car ferry, heading off to France, and then I'll do some more work while I'm in France, and hopefully I've got a few interesting projects. Yeah, let's find one. These, which is a smart tag, and this has a very clever bit of Bluetooth technology, a battery that lasts about a year. It's got a button, you can click it, and it's got a 5-axis IMU, so it's got 3 axis of magnetometer, so it can measure the magnetic field and understand its position relative to the Earth. It's got an accelerometer, so it can measure movement, and it's got a gyroscope, so it can measure sort of velocity and acceleration. I used this. The batteries run out at the moment, but what I did with this is I made a universal remote. So I used the Bluetooth Low Energy HID, human interface device, HID, and I programmed this. First, I had to calibrate the uncalibrated sensors. So you hold it down and it goes into calibration. You have to spin it around in all axes, and it flashes a red light, and it gets the highest values of all these sensors and the lowest values. So it records the minimum, maximum of the magnetometer sensors, for instance, in 3 axes. And basically, once it's seen numbers that are in the range it already has, highest and lowest, it flashes green. So you basically rotate this until you get no red flashes. You spin it around this way, you rotate it, and then you put it down on a flat surface, and press again, and that then locks in those as the 0 and 90 degrees for the different sort of XYZ axes, and it also gets the any offset so that everything starts at 0 in that position. So then what I can do is I can measure its movement very sensitively. So if you were to rotate this, I use a HID and I rotate it clockwise. I turn the volume up using HID, rotate it anti-clockwise, and I turn the volume down using HID. So it's basically simulating key presses on a multimedia keyboard. And then if you turn it upside down and rotate it, I do next track, previous track. So I'll skip music, skip, 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 back, 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 back. And then if you press the button, I'll play and pause. So it gives you a full sort of remote control for music on a portable device. My sort of turning and interacting. I've got some interesting ideas for the boat for this, which I will share with you in the future. As I've got a Catamaran, it has 2 engines, and it's got sort of, my boat's got very similar tech to a radio control boat. So the sails are all controlled by one line. So it has balanced rotating mast sails. So it's basically very similar to a small radio control boat in a pond with one servo controlling the sail angles. And I can control every point of sail with one line. And that enables me, if I motorized my winch with a bidirectional winch, I could, and I motorized, I've already got an autopilot motor on my twin rudders. And if I then put a fly-by-wire on the engines to change the gearbox and the revs, or if I replace it, I could then have a completely fly-by-wire boat, which I could control with a device like this. So I could sort of turn it to the starboard, turn it to port, speed it up, slow it down. If I'm docking, I could tilt it sideways, and that would do a sort of a little bit of a zigzaggy step sideways, tilt it the other way, go sideways the other way, rotate it. For docking, I could spin the boat round because I've got 2 engines, just by adjusting the velocity, the acceleration on each engine and the direction, spin the other way. And I could be maneuvering my boat with my fingertips on a small white device. Anyway, it's an interesting idea, maybe a little bit crazy. And I probably have to have 2 of these because if I'm rotating this and the boat is moving, I need another fixed one to subtract so I know this is moving relative to the boat, not relative to the world. So anyway, it's an interesting idea, and I may do some work on that later in the year, and I'll get back to you on that. I'm going to give you a quick demo video of my my universal remote controls phones and laptops and certain TVs that have Bluetooth Low Energy inputs, typically Android TVs or Google TVs. So that's a little bit of extra for the people who watch to the end. I've also got this, which is it's a programmable logic controller. It's about £45, and it has multiple relays, which are up to 10 amps. So it has 4 relays. It has 8 inputs for voltages, so it can detect between sort of 0 and 36 volt, no, 6 and 36 volts. So I can detect if any of my circuits are powered, and it has buttons and a screen, and it runs off an ESP32, and it also has CAN bus, so I can probably, and RS485, both with a power, so I could run it off a NMEA, an old NMEA connection or a NMEA 2000 connection, and which is very low cost. It's designed for industrial control of like production lines and factory equipment, but fully programmable. Again with the blocky language you've seen, and I'm going to use this to automate some boat tech to take what I'm doing with
the digital part of my boat into the analog bit, so I can say turn the mast lights on, turn the anchor lights, turn the navigation lights on, things that I do when I'm sort of away from the boat. Turn the cabin lights on, make the boat look occupied. I'm on shore, and this is sort of industrial quality, fairly robust, and one of these can control multiple circuits, and then I can plug extenders into this. So if I plugged in this, that adds 8 more 10 amp relay, no, 4 more 10 amp relays, so the 4 on it, and the 4, so I can control 8 circuits altogether. I've got 8 digital inputs, so I could monitor the switch to see if they're on, see if they're off. Anyway, some things coming up. So thanks for watching to the end, and yeah, I will see you next week.